Hi, I'm Stephen Whitaker, a PhD student in electrical and computer engineering at the University of Michigan. Today, I'm going to talk about MRI, which is a common type of medical imaging. One problem that MRI has is that it can be hard to tell the difference between diseases, which makes it hard to prescribe the correct treatment to patients. I am going to discuss why this limitation exists, and also how the field of quantitative MRI addresses this problem. But first, let's talk about groceries. Here's a paper bag that has apples and oranges in it. You can see that it weighs 2 pounds. Now, given this information, can you tell me how many apples there are in the bag? What about how many oranges are in the bag? Clearly, I don't expect you to be able to give me the correct answer. There's no way to tell how many apples and oranges there are just given the weight. We would have to look inside the bag. So, what do apples and oranges have to do with MRI? Let's have a look at an MRI image. In this image, you can clearly see the structure of the brain. This is because the different tissues within the brain have different tissue properties. In MRI, the brightness of the image depends on tissue properties. So, if we look at this tissue here, that's one type of tissue, white matter. And if we look at this tissue on the edge of the brain, that's another type, gray matter. Gray matter and white matter have different tissue properties, which is why they appear different in this MRI image. Now that we understand how tissue properties affect an MRI image, we can understand how apples and oranges relate to MRI. The paper bag represents a tissue in an MRI image. The weight of the bag represents how bright the tissue is in the image. And the fruits inside the bag represent the different properties of the tissue. Just as the apples and oranges inside the bag affect the weight, in a similar way, the tissue properties affect the brightness of the tissue. So, while an MRI image is influenced by tissue properties, an MRI image does not directly tell us what those tissue properties are. A natural question is, why would it be important to know what the tissue properties are? If we did know them, what benefit would we gain? Let's look at 2 more MRI images. You can see that there is something wrong with each brain. You can also see that the 2 images look identical, which is problematic because each brain is affected by a different disease. The 2 diseases change different tissue properties, and yet the images look the same. Granted, these are simulated images, but the truth is that there are diseases that look the same on MRI. For example, in 2003, researchers at the University of Colorado found that many people who were thought to have multiple sclerosis based on abnormal MRIs actually had another disease, or even a migraine or high blood pressure. Returning to our fruit analogy, one disease might add an apple to the bag, while another disease might remove an apple and add 2 oranges. And yet the resulting weights end up the same, so you can't tell the 2 diseases apart. Now, with apples and oranges, it's no big deal. You just end up eating a different fruit. But with disease, if your doctor prescribes you a treatment for a migraine, that will do you no good if in reality you have multiple sclerosis. Now, let's return to where we started. Previously, I asked you if you could tell me how many apples and oranges were in the bag. I'm going to ask you the same question, but now you can see inside the bag. So, how many apples and oranges are in the bag? You're right, there are 4 apples and 4 oranges in the bag. It's starting to feel like a kid's TV show, isn't it? But that's the point. Now that we can see inside the bag, when we see 2 bags with the same weight, we immediately see that what's inside them is different. In MRI, the way to see inside the bag is through quantitative MRI, which is my field of research. As the name suggests, quantitative MRI assigns numbers to tissue properties. So, instead of just relying on how bright the image is, or just looking at the weight of the bag, we can know what the tissue properties are, or we can see how many apples and oranges are in the bag. As we discussed previously, 2 different diseases can appear the same in an MRI image, but if we instead look at the tissue properties, we can tell the difference between the diseases. Quantitative MRI works by taking different MRI scans of the same part of the body and calculating tissue properties from those images. The downside, of course, is that more scanning means more time in the MRI scanner. However, quantitative MRI gives information about tissue properties, which allows doctors to more accurately diagnose disease, leading to better treatment and further study of diseases. Thank you for your attention. I hope that you learned something today.